In this video, I'm going to show you about details about the sensors and its classification. So, as we know that everything what we read in the books or any textbooks on reference books are basically nothing but measuring instruments. Especially if you are studying in instrumentation and control, then each and every subject consists of instruments which is going to measure a physical quantity that is related to industries. So sensors is one of that. So a sensor is a device that measures a physical input from environment and convert it into data. It is a device that senses something in process control. Example, automatic door in malls. Suppose if we went to some big malls or any five-star malls, then we see that, or any airports also, then we see that there is a door which is automatic door which presents our coming towards the mall or entering towards the mall, and then it automatically opens, and when we cross the door, then it automatically closes. So this system is created by using the sensors. The sensor senses our presence nearby the door, and it opens, and then when we are not there, then sensor senses that anyone is not present, so the door automatically gets closed. So what is the need of sensors? The need of the sensors is for automation. As we know that everything in this era or in this century, 2021 century, is dealing with automation. No one wants to work from their own hand, so everyone is relied on automation system. So for that system we need sensors. And for IoT applications means that if we want to making some what we can say, we can if we want to make some Arduino based systems, like automatic door system that I have mentioned earlier, and in food processing industries also, and if we want to build a small car using the Arduino, that's also for this purpose we can use the sensors. So the other things which we can measure through the sensors are temperature, humidity, pressure, proximity. Proximity means, I think temperature you all know, humidity also you all know, pressure, and then proximity. So proximity means the nearness of an object, that is the presence of the nearby objects. This is called the proximity. Length and displacement. Actually, the block diagram is of the sensors is that physical changes, it enters the sensor, and that the sensors gives the output signals. Now about the classification of sensors. You can find a number of classifications in Google or any platform, that in different platforms there are different classifications. But in this video I'm going to classify the sensors in four major categories, like according to power or energy supplied, according to various measurement objectives, and according to the principle of operation, and according to the output signal. So if we consider the classification of sensors based on the power or energy required, then we can classify it into two types, that is the active sensors and the passive sensors. So what is active sensor? Actually the sensors which require the power supply, external power supply basically, which is called the active sensors. And passive sensors are those sensors in which no external power supply is required. Means we don't have to give any external power to it, it will work from its own. So as you can see that active sensors, example is photoconductive cell and light, we can say that lidar. Okay, so then passive sensors, that is thermometer. Suppose we are having a high fever, then we use the thermometer. Hg means mercury thermometer to measure our temperature. So this does not require any power supply. So in this case this is called the passive sensor. Now according to the output signal, so if we consider that the output is analog or digital, then we may classify the sensors into two major types, that is the analog sensor and digital sensor. So analog sensor is giving the analog output, and digital sensor is giving the digital output. So analog sensor, having the example of tachometers, analog tachometers. Basically analog and digital means that in analog, uh, we measure the quantity using some sticks. There must be, suppose you are in speedometer, okay, you are. So analog and digital sensors are those, uh, like if suppose we are riding a bike, then there are some speedometers which tells that at what speed our vehicle is moving. So some in some bikes, especially the older day bikes, we can see that there are some stick like substances that uh, gradually goes up to 40, 50, then 60 when we increase our speed. Then it decreases when we reduce our speed. So this system, in which there is no digital displays there, this is called the analog system. So the sensor actually gives the output like that only. This is in the analog form, and in a digital sensor, uh, the same output will be in the digital form, that is 50, 60, it will be written in the display. Okay, so I think you understood the concept. So the next thing is that according to various measurement objective, like we want to measure different parameters or different quantities, okay, then we can differ the sensors in various types. So the first type is temperature sensor. If we want to measure the temperature, uh, basically the temperature sensors are used in boiler or gas turbines. You can, if you went to some industries, then you can see that there are big boilers in which or this you can also see that there are various machines which are producing the streams. Okay, so for controlling that stream or the temperature inside the boiler or the stream, so we have to use the temperature sensor. The next one is the pressure sensor. So pressure sensor is the same as the temperature sensor, but it senses the pressure. Okay, it is also used in boiler and gas turbines. Then there is a level sensor. Suppose we are controlling a water system, then there is a tank in which the water is filled, and there is a tape, okay, and we are using the water through the tape. So the level actually goes down, okay, when we use the water. So for that purpose, to determine the level of the water, we can use the level sensors. Okay, this is also used in the petroleum refineries. That is here it is written that level sensors are used in oil or water tank boiler. Okay, the next type is the displacement sensor. Okay, so displacement sensor is used to measure the distance and position. Okay, like LVDT. This is a inductive sensor also. We will read this in later slides. And capacitive sensor and robotics. Okay, so capacitive sensors and LVDT are used in the robotics application. Robotics is nothing but what we see in our everyday life is nothing but a robot. Okay, or the machines we use in everyday life. So the next is flow sensor. Suppose there is a piping system and water and oil or other fluid substances in the industries are flowing gradually. So we can determine the rate of the fluid flow by using the flow sensors. Okay, like you can see the example, the flow meter in industries. The next is speed sensors. To detect the speed of an object, that what I have said in the analog or digital, that if we are riding a bike or a car, then the speedometer, this is actually based on the speed sensors. Okay, the next is according to the principle of operation. Basically there are certain operations on which sensors works. So if we consider the operation of their working, then we can classify it into major types. Suppose we are having the proximity sensor. Proximity means I have said earlier also that it detects the presence of nearby objects. Okay, that is what here is written: detects and measures distance of nearby objects without physical contact. Okay, there is a short note that you have to remember. What is nominal range? The maximum distance a proximity sensor can detect, this is called the nominal range. Okay, or operating range also you can say. There is proximity sensors types. So the first type is inductive type. Here I have not mentioned such details about the sensors types, means proximity sensors types. You can refer to Google or any other books essential books to know more about this on what working principle it works. But here I have only mentioned some basic concepts regarding the sensors. So this is not sufficient, but this is not sufficient, but it is for your basic knowledges only. So you can refer to other books to know more about it. So the first thing is the inductive sensor. Inductive sensor actually senses the presence of metallic objects only. Suppose there is a conductive material, okay, so it can sense the conductive materials only, okay. It cannot sense paper, wood, and that kind of things, okay. So the range here you can see the maximum resolution, excitation frequency. I don't have to discuss this. You can make a short note on it also, or you can take screenshots also. The main advantage is that this is not contact measurement. That is, inductive sensors. In inductive sensors, we don't have to touch any object. Okay, without touching the object, we can measure the distance. Okay, then it has high resolution, high frequency response, and the disadvantage is that it works on only conductive materials. That what I have said earlier. Okay, the next thing is capacitive proximity sensor. Actually, it detects the dielectric targets. Suppose paper, plastic. Uh, this material is only detected by capacitive sensors, and the disadvantage is that only that it measures the dielectric substances. And another disadvantage is it is used for only short ranges. Okay. The next thing is Hall effect proximity sensors. Hall effect proximity sensors detect the change in the magnetic field when permanent magnet comes in close. Okay, so close proximity to it and generates a signal. Actually, what Hall effect does, Hall effect creates a magnetic field. Okay, suppose a permanent magnet and some magnets are there, which is detecting the presence of the objects by creating a magnetic field. Okay, so in this manner, Hall effect proximity sensor works. Okay, the advantage is it has very low cost and it has high stability. Okay, and the disadvantage is maximum sensing distance is only 10 centimeter, which is not enough for a good measurement, you can say. And the presence of offset voltage is nothing. There are some errors due to which the output becomes zero, so this is offset voltage. So there are the advantages of Hall effect proximity sensor. The fourth one is the optical sensor. Optical sensor actually used to detect the light intensity. Actually, it uses beam or diffused beam like things to measure the presence of the objects by incident and reflected that manner, what we have read in the physics. Okay, so the advantage is that it is small in size and it is insensitive to vibration or shock. Suppose any vibration or shock like things occur, then the sensor will not get disturbed. Okay, the next thing is the disadvantage. So disadvantage it is, as you know that the light beam thing is totally depend on the dust free environment. So for sensing any object, it requires a dust free environment and low moisture environment, that is clean environment. So this is a major disadvantage. And proper incidence of light necessary means we have to the incident ray of the light, okay, this should be clear so that we can get the actual measurement or actual sensing. Okay, the last thing is the ultrasonic sensor. Ultrasonic sensor I have discussed in a detailed manner in my previous video also. You can go and check it out. This is nothing but this is a sender and transmitting mechanism. There are actually the ultrasonic module having the two cylindrical shaped things. One is transmitter and the second one is receiver. One is used for transmitting the ultrasonic waves and the second is receiving the reflected waves. Okay, so this is the mechanism and detects presence of object using the ultrasonic waves. So these are the major categories of sensors, and I think you have gone through it and you like the video. So take care and bye bye.